Hey everyone, Jordan here, back with another Proto Tech Tip. Today we are going to be running down the 5 most common minor modifications we will make to customers' designs in order to minimize cost and lead time when manufacturing your CNC machined parts. So, when you're designing a CNC machined part, there are several factors you have to consider. In order to turn your design into reality, you have to balance all of the required features of your design with the constraints of the machine. During the design process, it can be very easy to forget that small changes could wind up having a large impact on cost. With that in mind, let's run through some of the most common minor areas of your design we see here at Protocase that can drive cost and lead time up. Number 1, corner radius. You may remember us discussing corner radius in a previous Proto Tech Tip. We've got the link to that below. Corner radius is one of the most common things we will modify in a customer's design. As a quick recap, in order to machine an inside radius, we need to use a tool that has an equal to or smaller radius than the corner, or else it won't fit. Smaller tools are weaker and therefore take more time to machine. Time is money, so inside radius should be kept as large as possible. In our experience with mechanical designs, sometimes corner radii are critical and sometimes they're not important. Sometimes the corner radius only exists in the design due to the fact that it was the default setting in the modeling software used. In this case, we've added cost to our design for a feature that we don't even need. So, when we see a corner radius that in our experience looks like it may not be critical to your design, we will want to discuss modifying them with you to minimize your lead time and cost, and give you the full modified design to review and approve. Nothing gets machined until you give a sign off. Number 2, minor tolerance changes. Tolerances control the precision to which your parts will be made. In a similar vein to corner radius, making them tighter when not necessary can inflate cost and lead time. Most drawings are made using templates with a title block and then adding the CAD drawings. In the past, we have seen situations where the tolerance from the default title block are tighter than what the majority of the design actually requires. When we see what looks like a tolerance that may be unnecessarily tight, we may want to discuss modifying it. Of course, we will always confirm with you that the tolerance change is acceptable through our correspondence at quoting and design approval. Number 3, edge rounds. Edge rounds are small radii that are applied to the top edge of a part. This adds a small complexity, as the fastest way to do this is with a corner radius forming tool. A forming tool can only do the size it was made for. If you specify a radius that we do not stock a tool for, we can still accomplish the geometry you need using a technique called surface profiling. However, this process is more time consuming and therefore more expensive. Chamfers are a similar geometry to edge rounds, except that they are straight instead of a curved profile. This actually helps to relieve constraints on these edge finishes significantly. With a straight edge tool, a chamfer mill, we can achieve any size chamfer since we can hang the tool off one side of it or another to make multiple passes. These options are not possible with edge rounds, making chamfers a much more flexible solution. So, unnecessary edge rounds can add time and cost to your design. But a few ways to combat this is to use a radius that matches a stock tool, use a chamfer instead, or eliminate the radius altogether, if possible. Check out our website to see our stock tooling. Also note, your part will still have the sharp edges broken with a small chamfer unless you specifically ask us not to break the edge. Number 4, tapped holes and floor thickness. Tapped holes are an incredibly common feature on machine parts. First a hole is drilled, and then a tool called a tap is inserted into the drilled hole where it forms or cuts the threads to match a bolt, screw, stud, or other fastener. Tapped holes literally hold our world together. An important feature of tap geometry is that they have tapered ends that are non-thread forming. These tapered ends help guide the tap into the pre-drilled hole on center, forming threads within tolerance. These tapers, however, have an unintended consequence. They require us to drill a deeper hole than you might expect to form threads to a specific depth. For example, say you want a threaded hole that is a 1/4 inch deep. That means that our drilled depth must be at least a 1/4 inch deep plus the tapered length of the tap plus some allowance to make sure we don't break anything. Now, let's say that your tapped hole runs into a floor and say that it's pretty thin. Since our drills have pointed ends, drilling down that extra depth to accommodate our tap might cause us to create a dimple on the floor, or worse, blow right through it. This is where our design team comes in. Upon design review, our team may suggest the minor modification of reducing the thread depth called out on your 3D model or drawing. As always, we will get your approval first to make sure the reduction in the tap depth doesn't affect the functionality of your part. If it does, maybe we can discuss some other modifications, like making the floor thicker. Number 5, tapped holes and overall depth. Tapped holes are used so frequently, we wanted to talk about them twice. While these are common features, there's a way to make them cost more than necessary, and that's depth. The tapping process involves a lot of torque on the tool, and the deeper the threaded portion of the hole is, the more issues that can develop with tool breakage. Breakage of a tap usually results in a scrap part. Keeping threaded portions of holes to the minimum you require can help prevent costs associated with the increased risk of breakage. Again, check your software's default settings for the thread depth to make sure you aren't requesting a thread that's unnecessarily deep. Should you require those increased depths, we can accommodate, but we may check in with you to make sure they are not unnecessary. If we can reduce your tap depth, we can save you time and money. So that's all for this week's Proto Tech Tip. As always, Protocase can manufacture your CNC machined or sheet metal part designs in 2 to 3 days with no minimum orders. Check out our website for all the different stocked material and tool options, as well as design constraints mentioned today. Thanks, and we'll see you next week.